All right, yesterday in class we did the resonance lab. We did the pre-lab questions together and we had the group's question stated. We did not talk about what you're writing out the plan, but we told you what to do. So make sure you write down what you did to collect data. So what did you change and what were you measuring? And then make a sketch of your setup. And then you should have the data table from yesterday filled out with headings and units. Frequency is supposed to be in hertz, Hz. Period is in seconds. Height and wavelength are both centimeters. And then you should, of course, have your 6 different data points from yesterday. And then you were also supposed to have a graph made from yesterday. And that's where I'm going to pick up. We're going over the summary questions on the back of the lab with you. On your graph, you want to make sure that your y-axis is wavelength in centimeters. Your x-axis should be period in seconds. And then if you didn't have Google add the equation to the top like I did here, either do that before you move on or make sure you have found the slope and the y-intercept before you move on. So you don't have to have made your graph in Google Sheets. If you hand graphed it, you need to find your slope and y-intercept before you continue on with the summary questions. Another thing to note, if you haven't yet made your graph, using the graph in Google Sheets is way easier because your period numbers are super small and it's hard for a lot of kids to graph those. So I'm going to start going over the summary questions on the bottom. Question number 1 asks, what is the numerical value of the y-intercept and what does that mean? So when I look at my graph, it looks like my y-intercept is about 0. If I actually look up at my data table, I'm getting negative 1.14. The unit for that should be the unit that is on the y-axis, or centimeters. Having a y-intercept of a small number, either positive or negative, is not unusual because this data is really hard to get consistent data. I'm pretty confident, I did this graph several years ago, that I actually calculated what the wavelengths were supposed to be with the frequencies and not actually calculated the data. So this is more like ideal data than you would have. It's hard to get exact, accurate measurements, so some of your numbers are going to be a little off, and that's okay. But the y-intercept really should be 0 centimeters. That's what we should get in an ideal situation. And then when it asks what does that y-intercept mean, we don't want to say that's where the graph starts. Y in terms of what we were doing is the y-intercept 0. So on the x-axis, that's period. So if the time for that tuning fork to oscillate or move back and forth was 0 seconds, then we would expect a wavelength of 0 centimeters. So if it took literally 0 seconds for a tuning fork to move back and forth once, our wavelength should be 0. So that's what I would write for my conclusion question. If the time to oscillate was 0 seconds, then the wavelength should be 0 seconds. For number 2, you want the numerical value of your slope with units. From Google Sheets, that's going to be the number that is before the x. So my y-intercept, or sorry, my slope is that number right there. 34,615. I also want to include a unit with that. So for your slope unit, it should always be whatever unit's on your y-axis, so centimeters, divided by the unit on your x-axis, seconds. Now this number here is my slope. No one should have that slope, but it should be a ballpark somewhere between 40,000. And a lot of kids yesterday when they found their slopes thought this was really, really big. But we'll talk about what that means and why it's not that it's a reasonable slope to have for this. But when we get to question 4, we'll talk about why this is a reasonable number. Then question 3 says, what does it tell us about the relationship between the two variables? Well, if my slope is centimeters per second, that means every second the sound wave is moving 34,615 centimeters, or there's 34,615 centimeters every second. And then for question 4, the vocabulary term for this If it's centimeters per second, this is a unit of speed. So this is a specific speed. This is the speed. But now what we were doing yesterday is we were measuring the speed of a sound wave. So this is the speed of sound. And then if you remember from last week when we were talking about the Doppler effect, the speed of sound we accept to be 340 meters per second. That's a ballpark, so it gets a little faster if it's, warmer out, or, air pressure and stuff will all affect this. But 340 meters per second is what we expect. So if we're getting our slope in centimeters per second, to convert that to centimeters per second, we want to multiply it by 100. So then that gives me an accepted value of 34,000 centimeters every second. So now remember, I think I told you, I'm pretty sure I didn't actually measure these numbers. I calculated what I should have gotten for a wavelength. So that's why mine is probably closer than yours. So then you want to make sure you have everything done in the graph or in the lab, including the front side and your graph. If you need to print off a copy of your graph and grab it, that's fine. Make sure your name's on it and then put it in the turn-in bin. And then you're going to work on the next worksheet in your packet when you're done with this.